Hey guys, I have this question from section 3.2, and I thought this would be a good review, a good video to create and share with you guys. So we are given this function q of x, and we are asked to find the following. We are asked to find critical points, the relative max, relative min. We are asked to identify intervals where that function is increasing, decreasing, those inflection points, and we also are asked to test for concavity. So these problems, if you've worked some of these out, these multiple part questions, they can take some time. And so I don't want to create a video that is super long. So what I plan to do is break this up and create multiple shorter segmented videos for you guys so that you are able to jump to the content that you want to watch. So in this content or in this video, we will be working on this part A. We will work on finding the coordinates of the critical points and then identifying the max and the min. So let's jump on that really quickly because, again, I don't want to take too much of your time. So I'm coming to the side over here, and the first thing I want to do is rewrite that function, q of x equals x over x squared plus 36. And what I would recommend before we begin looking for those critical points is I would look at that original function and I would ask myself what the domain of that function is. Or in other words, what I'm getting at is sometimes we have vertical asymptotes, and those asymptotes can show up when we're looking for our critical points. And they're not necessarily a max or a min or an inflection point. Sometimes they are vertical asymptotes. So I think it's a good idea to begin by looking at that denominator and asking yourself if there's any numbers that would cause me to get a 0 in that denominator. In other words, where is that function undefined? But for this particular function, if I look at that denominator right there, there is no number, no real number, such that if I were to substitute that number into that denominator, I would get 0. So that function exists everywhere. So that's good. There's nothing to make note of, but always pay attention to that. But I want to find the denominator, or the derivative. And the way we're going to find the derivative here is by using the quotient rule. And so that I refer to that as the bottom times the derivative of the top minus the top, let's put it all in parentheses, times the derivative of the bottom all over that bottom squared. And that's it, but we do want to simplify it. So let's simplify this derivative. So if I take and multiply everything I have here in the first part by 1, that gives me x squared plus 36. And then I have minus, and over here behind that minus sign, I have that 2x squared. And in the denominator, that gives me x squared plus 36 all squared. And if I simplify that, that will give me, what will that give me? That would give me a negative x squared plus 36 all over x squared plus 36 all squared. So that's my derivative. So just as a reminder, part A, what we were looking for, and remember, you can always pause this video to read these questions a little bit closer, but it's asking for those relative extrema. And so to find that extrema, I need those critical points. And the way we find our critical points is by determining where our derivative is equal to 0 and where I put f of x. Let's write this correctly since we have a video here. That is actually my q of x. And then where that q of x, or q prime of x, does not exist. So for this function to equal 0, for a rational function to equal to 0, that would mean that the numerator would need to equal 0. Okay, so I have that set up. Let's solve this. So I would bring that negative x squared across, and what I get is 36 is equal to x squared. Take the square root of both sides, and I have there that x is equal to positive and negative 6. And if I look, I think I left my answers there. I do see that I have 2 points at positive and negative 6. So, but I don't have the answer just yet. How do we get there? But let's before we get there, let's look at this other part. I need to also determine where that derivative does not exist. And if you remember earlier up here up top where we highlighted and talked about that derivative or the denominator, where the domain, that function exists everywhere, the same idea holds true here. I have the same terms in that denominator. We have that x squared plus 36, but this time it is all squared. But because I have those same terms there, and I can write this down, what happens is if I try to determine or solve this for 0, set this thing equal to 0 and solve for x, I get a statement, I get a false statement or something that is not true. We know that it is impossible to square a number and get a negative 36, at least square a real number. So what that tells me is that that derivative, it also exists everywhere. And these are the only 2 critical values that we need to consider. Okay, so how do we consider those? So what I would do is draw my number line and put those critical values on my number line. And I'm going to do this, let's see what else it's asking for. Well, no, we would do this one piece at a time. And so if we go through the theorems and the steps that they have given, what we would do now is test each area of this number line. And it doesn't matter which numbers you choose, just as long as those numbers are within those intervals. For example, I would first need to pick a number that is less than negative 6. And so I might let x be equal to negative 7. So we would take negative 7 and we would substitute that negative 7 into our first derivative. And that would give me the opposite of negative 7 squared plus 36 divided by negative 7 squared plus 36 all squared. And so I would simplify this, and this would give me a negative 49 plus 36 divided by 49 plus 36 all squared. And if you guys were to sit in my class, I would tell my students at this point that I'm not really interested in the actual number. I'm really just interested in the sign of the number. So what I mean there is that I know that negative 49 plus 36 gives me a negative number. And in the bottom, I'm squaring. So those numbers there are going to be positive. So I have a negative divided by a positive, and that is negative. So if my derivative is negative, that tells me that I am decreasing there for that particular interval. And so let's move to the next. I can pick a number between negative 6 and 6. And there I could choose to let my x be equal to 0. And then I would take 0 and substitute that into my original, or no, my first derivative. And so that would give me the opposite of 0 squared plus 36 divided by 0 squared plus 36 all squared. And again, I'm just concerned, all I'm interested in here is the sign of the number. So on top, I really just have 36, positive 36. And in the denominator, I have a positive 36 squared. So that's positive divided by positive. So because that gives me a positive derivative, and that tells me that over that interval, that function is increasing. And now let's test that last interval there. So I can let my number then, I can let x be equal to 7. You could choose 7, 8, 9, 10, any number you want, just as long as it's greater than 6. And then I would take 7 and I would substitute 7 into that derivative. So then that would give me negative 7 squared plus 36 divided by 7 squared plus 36 all squared. And again, that's very similar to what I had over here with that negative 7. So I have that negative 49 plus 36 divided by 49 plus 36 all squared. And what we see there is in my numerator, I have a negative outcome, and in the denominator, I have a positive. And so a negative divided by a positive is a negative. And what that tells me is that over the interval, that function is decreasing. Okay, so why is that helpful? So let's pause. You can pause this video anytime you need to, but let's take a minute here and go back and look at the question. It's asking me what are the coordinates of the relative extrema. And so what I'm looking for are those critical points right now, and they tell me where my extrema occur. And what I just determined here is what type of extrema they were. So, and how do I know that? Well, here my function changes from decreasing to increasing. And at that point right there where I changed from decreasing to increasing, by definition, I know that that must be a relative minimum. And then on this case here, I'm changing from increasing to decreasing. So I know at that point there at 6, where my function changes direction, that must be a relative max. So I can write here, let's come over to the side, that we have a relative max at, and what we know right now that it is going to be at 6 something. And then I have a relative min at negative 6 something. So how do I get those outputs, those y values? What we do then is we take these values that we have and we substitute those into the original function to get those y values. Let's see if I can zoom out because I do not remember what that function was. So q of x, which is right here, that is 6 divided by 6 squared plus 36. And that gives me 6 divided by 36 plus 36. That is 6 divided by 72. So that should be 672. And then we're going to do the same thing for that negative 6. And so that would give me negative 6 divided by negative 6 squared plus 36. And then that's going to be very similar to what we just had. The bottom will simplify and still give me 72. But in the numerator this time, I have a negative. Let me make this a little bit larger, give myself more room. But in the numerator, I have that negative 6. So that's negative 6 over a positive 72. And if I look, okay, so we have to simplify, and I did not simplify. So if I simplify those, 6 goes into 6 one time, and of course 6 goes into 72 12 times. So, and same thing here, 6 goes into negative 6. I have that negative 1, and then the 12. So let's come over here and let's simplify this. Let's write it in simplified form. So that would be, give me just a second to get this eraser correct. Let's get this correct where we can see this. So I have my relative max at 6 and 1/12, and my relative min at 6 and negative 1/12. So I would have got points deducted there because I did not simplify that answer. But that is part A. So if you guys have any questions with part A and what I just did, just reach out. I'll be happy to help.